All right, we're continuing here at Splash. We're with the great Mark Miller. Thanks for coming on Channel 9.
You're welcome.
So the last time we talked, you spent some time kind of digging into Kaha and sort of this notion of the importance of security in programming languages. What have you been up to recently in that?
Pushing forward on that agenda.
Okay.
We now have SES, as I described before, which is a subsystem for the JavaScript portion of Kaha. SES stands for Secure ECMAScript.
Okay.
But it provides the same security for JavaScript that Kaha has always provided, but on an ECMAScript 5 conforming platform, it does it without translation.
Interesting.
It does it by the means I've discussed earlier, but the exciting news is that the development tip version of all the major browsers, as of literally just a few days ago, is sufficiently conformant to ECMAScript 5 that the SES initialization script, with some repair added to it to repair some of the remaining deficiencies, is now able to turn the existing browser environment into a safe SES environment on the development tip of all major browsers. Now, development tip means that some of these things are in alpha or beta, so it's not yet in the released version of the browsers. But Kaha continues to maintain, of course, the translated version, with which we continue to support ES3 browsers safely all the way back to IE6.
Nice.
And we're converging the translator form and the translation-free SES form, so that programs written for one are compatible with the other.
Okay.
And the integration we're building up to, we're not quite there yet, but we should be there rather soon, is that we do detection of the browser platform to see, is this a safe target for SES? We are doing that detection right now. What we're not quite doing yet is auto switching, whether if you're deploying through Kaha, you want to say, if you're deploying to a browser in which SES can run safely without translation, then we deploy that way. If you're running in an older browser, then we deploy through the Kaha translator.
Okay. Which is the server-side filtering.
Server-side filtering and translation.
Yes.
We do a source-to-source translation of the JavaScript, and the reason we do that is on ECMAScript 3, we don't have the means to get the JavaScript to perform the protection that we need on itself. The ECMAScript 3 just lacks the primitive. So instead, we do a source-to-source transform where we inject essentially runtime tests into the code in order to ensure, by virtue of the injected runtime tests, that the code stays within the object capability subset of JavaScript.
Okay.
Now, the translator is more complicated. I mean, there's more to it than what I just said, because the translator is also implementing essentially the full ECMAScript 5 semantics by translation to ECMAScript 3. So all the extra state that ECMAScript 5 manipulates has to be encoded in ECMAScript 3 state.
Understood.
But we do that in such a way that it can still interoperate very smoothly with untranslated ECMAScript 3 code.
Okay. Now with ECMAScript 5,
yeah,
you introduced the what is it?
No,
the strict mode.
Strict mode, yes.
I know that's a big thing Crockford was into.
Yes.
Talk to me about what that means. And so if I use that,
okay,
do I need to use Kaha?
Yes. Well, you need so let me be very clear. Once you're on an ECMAScript 5 platform, by SES we mean what you get when you run the initialization script on a adequately conforming ES5 platform. So in that sense, you are just using ES5 since you're using it without translation. But you're using it, and essentially you can think of init SES, the thing that initializes your environment, as being like loading a library, but with some constraints. You have to load it earlier, and once it loads, it constrains the environment so that what can happen from there is only in the object capability safe subset.
Okay.
And I can go over what that subset is. The things that we remove from ECMAScript 5 to make SES, or the restrictions that we impose,
okay,
to a first approximation, do not affect well-written JavaScript programs. in the sense that the things we remove are already things that are recognized as not being good JavaScript practice.
Okay.
Okay, so let's go ahead and enumerate those.
All right.
But first I want to finish up clarifying the terminology.
Okay.
So, so SES is about the JavaScript portion, and it's only about the JavaScript portion. Caja is the larger platform that includes SES or the translator, depending on the version of the browser, but also includes our translation and protection with regard to HTML, CSS, and the DOM API.
Okay.
And protecting the DOM API was an incredible job all by itself. I often, speak about the JavaScript portion because it's sort of the sexier thing to speak about. But in terms of where the complexity went, there's a tremendous amount of work and complexity that went into securing the DOM API.
Okay.
Okay, but right now I'll just speak about, continue speaking just about the SES portion. The other reason why we separate out the name is we intend to promote SES, bring SES to the Standards Committee.
Okay.
That was always the intention, to standardize that as initially a variation on ES5, at some future time a variation on ECMAScript Next, ECMAScript Harmony, but to standardize this object capability portion as something that can be now eventually directly supported by the browsers. You don't have to do it by loading an initialization script.
Okay.
Okay. Now, starting from ES5, the restrictions that SES imposes are, first of all, that all code be in strict mode.
Okay.
So when you load in the initialization script imposes this constraint on all code that arrives into your environment through eval or the function constructor. So that's the means by which you load untrusted code.
Okay.
As an initialization script, as opposed to a browser-supported standard, we're not in a position to constrain code that comes in through the script tag to strict mode, nor event handlers like on-click equals. We're not in a position to constrain those because we're not in a position but with SES by itself, given that we're leaving aside Caja's HTML translator. So if you're just using SES by itself, it's sort of up to you to make all of the script code strict, but the threat model, excuse me, I have a bit of laryngitis.
Okay, understood.
The threat model that you have when you're using SES by itself is that the code that's coming in through the script tag is the code that owns that JavaScript context, so it has the power to do everything that JavaScript context has the ability to do. So it has access to document and window and all of the powerful objects that exist in that JavaScript context.
Okay.
What it does is it uses eval or the function constructor, some other things we provide in our API, but let's just talk about eval and the function constructor. It uses those as the means to bring in other code that it does not trust into that environment, such that it can now, basically, you can imagine like maybe the containing page is a framework and it's bringing in third-party plugins. Okay. But it doesn't have to trust the third-party plugins in order to plug them in. Instead, by bringing them in through eval, the eval that we provide, which is a wrapping of the original eval that's installed by our initialization script, imposes constraints so that the containing page can bring in an untrusted plugin safely and know that it can only do things that the containing page authorizes it to do. Okay. Okay, so now let's talk about the restrictions that bring this about. So the first thing is, it enforces that all code comes in through eval is in strict mode, and it does that essentially by just prepending use strict before taking the string to be evaluated and handing it off to the real eval.
Got it.
Okay. Init SES itself imposes the constraint that all of the built-in objects like array, object.prototype, all the methods on those prototypes, that all those built-in objects are made transitively immutable. And it does that by using ECMAScript 5's new primitive object.freeze, at initialization time, we go over everything that's in the standard built-ins, and we freeze it. Before we freeze it, we remove everything that's not on our whitelist. Our whitelist includes all properties that are specified by the ECMAScript 5 standard, and includes the subset of the additional properties that are part of the standard web, part of the de facto web,
Okay.
the additional properties that we consider to be safe. Okay? Now, I want to point out that so far we've only enforced best practice. Now that strict mode exists, the restrictions that strict mode itself enforces only correspond to best practice JavaScript. And now that strict mode is available, good JavaScript code should be written to be compatible with strict anyway.
Yeah.
Okay. In addition, it's become common wisdom not to monkey patch the built-in objects. You don't monkey patch object.prototype, you don't monkey patch array.prototype. Some libraries violate that. We have a way to accommodate that, which I'm not going to speak about today because it's more complicated.
Okay.
But in an SES environment, we freeze all the built-ins. The most popular library, jQuery, does work with SES.
Cool.
Okay, and then the final restriction that we impose is that, and this is the one that will sound painful, and then I'll explain why it's less painful than it sounds. But the final restriction we impose is that the string being evaluated cannot name any global variables other than the global variables on our whitelist. And once again, the global variables on our whitelist include all the global variables specified by the ECMAScript standard. But it does not include the standard browser extensions like window and document, which are on the browser side, not on the ECMAScript side. So what this means is that the code being brought in through, if it's being brought in simply through eval, it can be JavaScript code that's simply coded to JavaScript best practices, but it can't be yet, until I take the next step, the full expression of JavaScript code to run in a browser that follows best practices. Okay. I mentioned besides eval and the function constructor, we also have our own evaluation API. So we have something that's essentially a 2-argument eval, where you have the string to be evaluated, and you provide an environment object that acts like the pseudo-global, in which you can provide properties on the environment object you provide that the script being evaluated sees as its globals. Okay, now let's put the whole picture together. Okay, you have, let's say, an old system that was using plugins from third parties, where it had to be vulnerable to the plugins, because it had no way to secure itself against the plugins, given that it wanted to directly invoke the plugins and let the plugins directly invoke it. It wanted to expose a rich, direct object-to-object API to the plugin. Okay. And since we're saying it's an untrusted plugin, let's assume it was using the script tag to do a cross-origin script load. Okay. Now, in order to secure it in the new world, it can no longer bring it in through a cross-origin script tag, because, as I said, script code that runs in an SES environment runs with access to all the powerful globals, with direct access to the real window and the real document. Okay. If the HTML containing the script tag is rewritten by the rest of Caja, then the HTML translator maps that automatically to what I'm about to describe. But let me just describe it manually if you're just using SES by itself. So HTML5 gives us cross-origin XHR. So where you were doing a load through a cross-origin script tag, instead you do the same load with a cross-origin get on an XML HTTP request. You bring in the text of the source code, and then you evaluate it with the containing page evaluates, let's say, the plugin, the source code for the plugin, with our eval, and either the plugin is just written to plug into the framework, it's not written to be a citizen of the web. That's one possibility, in which case just using the simple eval that just restricts it to the JavaScript globals might be fine. Or it's something that was written assuming it's running in the web, in which case it uses the global variables documented, window, et cetera, in order and XML HTTP request itself, in order to gain the ability to do things to the environment that assumes it's running it. In that case, what the containing page does is it uses our DOM wrapping library to create a virtual window and a virtual document that can be served out of a subtree of the DOM of the containing page. Okay? And then you create a scope object, a virtual global that contains not the real window and document and XHR object, but whatever window and document and XHR object represents the access that the containing page wishes to grant to the plugin.
I see.
Okay? And whether it wishes to grant it that kind of environment at all, or whether it wants to grant it an environment constructed in a different way, is purely up to it. The SES part by itself is providing the containing page a mechanism by which the containing page can easily express a very wide range of security policy. The DOM wrapping library that we've created helps express a particular range of security policies that have to do with emulating a virtual DOM on top of the real DOM.
Interesting.
Okay. When I say virtual and real, I'm purposely making an analogy with the way a memory management unit in the hardware helps an operating system separate processes from each other. It's the basis for all operating system security. Is it presents the illusion to the program that it's operating on real memory addresses, and what the MMU is doing is basically just playing a name remapping game. It says when the program thinks it's accessing memory address 37, well, it's really accessing this other memory address in real memory.
Okay.
That means the program can only address a subset of the real memory, and the addresses by which it addresses it are different than the addresses by which that subset of real memory exists.
Yes.
In like manner, our DOM wrapping library presents the illusion to the plugin that it's accessing a real document and a real window and a real DOM tree. We're in fact exposing our wrappings of all that. We never give it a real DOM node. We presented only wrappings of that preserve the illusion, and the purpose of the wrapping is essentially the same, to perform name remapping games. When I think I'm accessing the root DOM node, I'm actually accessing the DOM node of a subtree of the containing page. I cannot climb out of the virtual DOM tree that I've got to get part of the real page beyond that, because it's simply not in my namespace mapping. I can't name those objects. Similarly, CSS class names are a global namespace on the containing page. When we bring in a plugin, we want to give it the illusion that it has its own private CSS namespace, but we only have one global CSS namespace to play with. So once again, we play name remapping games so that everybody seems to have their own private CSS namespace, and they're all isolated from each other. One plugin cannot manipulate the styles by which another plugin is rendered, unless the containing page hooks them up in such a way as to enable that on purpose. But the default is to keep things isolated.
Excellent.
Okay.
All right,
Okay.
so in terms of name remapping and mapping and stuff like that, you are going to be the one responsible for ensuring you do it very efficiently. You use the operating system analogy, it's super efficient at that level.
So first of all, I just wanted to make clear, since you said you, I'm part of a team.
Of course.
And in particular, the name remapping logic is mostly not my work, it's mostly the work of the team.
Okay.
The D'Amato library, which is because it wraps the DOM, but it's also Spanish for taming. We're taming the dangers of the DOM.
Okay.
And caja, by the way, is Spanish for a box, but like a strong box for like keeping money in.
Okay.
So in any case, so with so first of all, on performance, let's talk about JavaScript. When you're doing the translation-based, the cost of injecting the runtime tests and the costs of representing the built-in ES5 state by encoding an ES3 state costs you some performance. Now, on micro benchmarks, we're showing, no, actually on macro benchmarks, on macro and micro benchmarks, we're showing between no performance loss, this is for the translator, between no performance loss, but only on one micro benchmark, but on the macro benchmarks, I think never more than a factor of 3. I think it's like hovering around a factor of 2.
Okay.
And the micro benchmarks are fairly consistent with that, except that there's one micro benchmark that sort of touches us exactly. I mean, this always happens when you do micro benchmarks against systems. There's just some micro benchmark that just hits you where you're weakest.
Okay.
And it just kind of keeps poking at the wound. And so we've got one micro benchmark which we're doing a factor of 10, but that we're not seeing that on the macro benchmarks. So our translator is still doing very good. Now, the story with SES, oh, and there's also a factor of 2 expansion in the code size from the translation.
Ah.
Okay. Now, with SES, because we're not translating, we're still loading through our wrapping of eval, and we also have to initialize the frame, so there's some startup cost. But after startup, the code is running untranslated, so as far as JavaScript, the JavaScript part goes, it runs at full speed, no overhead. And the JavaScript code, once again, because it's not translated, there's no expansion.
Okay.
Okay. On the DOM wrapping, the DOM itself is so slow that for most issues, the cost of going through an extra layer of wrapping on the way to the DOM is not noticeable.
Okay.
Okay? Because the DOM itself is still the bottleneck. There was one exception to that, which jQuery unfortunately touched, which was node list. We finally figured out a solution that works both on ES5 and works on most browsers under the translator that enables us to emulate node list efficiently even on most old browsers, but not on all the old browsers. So there's still some old browsers where it's inefficient, but it works everywhere. So on SES and Caja on SES, there's a startup time lag. After startup, pretty much everything's running at full speed. You're really not going to notice the difference.
Excellent. Good. I mean, I think that's very, very clear. Thank you for coming on Channel 9. I know you got a talk you want to see, so I appreciate you. That was excellent explanation. I think it's crystal clear when you're making some really good progress.
Yes.
So right on. Nice to see you again, Mark.
Okay.
Cheers.
Same here. Good to see you.